Hello. There we go. Can hear the echo. That's nice. Okay. So, hello everyone. My name is Einar. I'm going to talk to you today about NestJS. The reason I wanted to do this talk was I often feel that there's not enough backend representation in these JavaScript meetups. So I wanted to introduce you to a backend framework that I like quite a lot. So our game plan is going to be we're going to go a bit over what is Nest, and then we're going to talk about a bit of event-driven architecture on the back end, and then we'll end it with a short demo of Nest. So the question of what is Nest is, it's easy to answer. It's a framework that lets you write REST, GraphQL APIs, microservices, WebSocket APIs, all in JavaScript, which should please this crowd quite a bit. But then again, we also have quite a bit of those already. We have Koa, we have Happy, we have Express, we have Fastify. So the bigger question is, why should you consider using Nest? And the answer I've come up with for that question is that of architecture. Because with Nest, you get this out-of-the-box structure. You get to compose your application from these smaller building blocks. You get to write code that is agnostic of its transport layer, and you write easily testable units. So I have this kind of a bit of a problem with Express and Happy and Koa and the like, because they don't solve this crucial problem of architecture. On one hand, that is great, because you get to do your own thing. You get to be cool. You get to write this from scratch, and that's really nice. But on the other hand, it means you can't really transfer your knowledge between Express projects. And I've touched upon many of these, and transferring knowledge from one Express project to the next is actually quite hard, because they tend to be written completely differently. And usually there are some mistakes made with architecture, because architecture is hard. So Nest was sort of a nice thing for me to discover, because it forces you into architecture. And it does some really great things with TypeScript as well. An instance of that would be it uses the reflect metadata API to do dependency injection. So going through those steps, some of you will be thinking, oh, that sounds like heaven. And others will be thinking, this is just Rails all over again. What are you doing? Why are you introducing us to this? And I would say, okay, I see where you're coming from. Because Rails, of course, was this thing where you were supposed to be able to transfer your knowledge very easily between projects, because it was so opinionated. But I would say Rails was too opinionated. It was too much magic, and I encourage you to do tight coupling and all sorts of things like that. But I would also say to you that Express, Happy, and all those others, they go a bit too far in the other direction. There's no structure. There's no way for you to take your knowledge into the next project. And that's sort of the argument I've made with Nest so far. Moving on from that, I want to talk just a bit about dependency injection and why it's a nice thing. First off, for those of you who don't know dependency injection, don't know what it is a pattern that allows you to invert control. That means classes are not in control of how their dependencies are created, or in other words, we want to separate the responsibility of using something from the responsibility of creating it. And what does this allow? It allows us to write classes that are independent of how their dependencies are created, and it also allows us, while testing things, to use different dependencies than what we do when we're running things. So how does that look in Nest? Here's an example. We have this cat service, allows you to manage cats. And you can see on the top there's this injectable decorator on top. Now, what does that mean? It means it's injectable. And this service, so under the hood, injectable actually doesn't do anything. It is a necessary part for Nest to use the reflect metadata API, because TypeScript will only emit this metadata for classes with decorators. So that's why we have this there. Secondly, how would it look when we're using this? And we go over to our cat's controller, and you can see that we've annotated that with this controller thing. And in the constructor, we see, we have this cat service there. We're not instantiating it, we're just saying Nest, please take care of this for me. And then you can see these two other decorators as well. They're the post and get decorator, and that's our way to do HTTP in Nest. We add these decorators, and because the controller has this string cats, this means we're talking about /cats. So if I post to /cats, this create method is going to be called, and if I get cats, this find all method is going to be called. Which I think is really nice because this allows us to write code that doesn't really care about the transport layer that much, and it's easier to test it that way. And Nest takes care of instantiating all of this for us. And even, cat service could have a dependency on something else. So when we're setting up this test harness, we don't have to think about that. So dependency injection, pretty nice to have, I would say. So with that out of the way, I want to talk a bit about microservices. And out of the box, Nest gives you transport layers for TCP, gRPC, RabbitMQ, MQTT, Redis, and NATs. But it's also trivial to add other transport layers, and I did so for 0MQ while testing this out. So highly recommend that. But again, to this point of we want to write code that's agnostic of its transport layer. Let's take a look at this math service or math controller here. This is what it would look like to write a microservice in Nest. We have this add method on top, it's just adding two numbers, and we have this sum method here that reduces an array of numbers into a single number. We're just adding all the numbers together. And then we have this message pattern decorator that says command sum, and this is us saying to Nest, okay, when I receive an event over this stream that matches this pattern, respond with this method. So our controller has no idea whether messages are coming over TCP, whether they're coming over RabbitMQ, MQTT, NATs, or whatnot. It doesn't matter. That we control when we create the service. So this is what it would look like to create a microservice in Nest. We say, Nest, would you please take my module and make it a microservice that listens over RabbitMQ with these options. But later on, like we're technical people, we're gonna think RabbitMQ is pretty old, MQTT is pretty cool. So what happens then? Well, we swap it out. We say, okay, Nest, please instantiate this microservice and use MQTT as the transport. And our code doesn't have to change because we don't care about the transport layer, and this is very important. However, my favorite part of Nest is the CQRS module, and that's a module that's like buried in the docs and not very much talked about. So I want to go a bit over CQRS in NestJS. You can add it to your project by saying yarn add nest CQRS, and so CQRS, for those of you who do not know, stands for Command Query Responsibility Segregation. It means we want to have a separate command layer from a query layer, and Nest kind of helps us with this. But why would you want this? Well, that's a good question. Let's take a look at some problem. We have this checkout method. It belongs in some service. What it's doing is it's looking at a user in the basket. It's getting it through some service, and then we're calling checkout on the basket. Simple code. If only all code could be this simple. However, marketing departments exist. And they come in one day and they say, there's this coupon craze going on, and we want to give everyone who shops with us over the age of 21 a coupon for alcohol, because now they can drink. But also, that's not enough. About 10% of these non-alcoholics as of yet shall receive 3 million credits. So how do we do that? As programmers, it's very easy to just go ahead and say, I'll just add an if statement. And fine enough, like it's simple at this point. If the basket has some blah, 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 we have an if statement and it's nested, and all of a sudden our code is smelly and it's messy, and that was easy. Why does our service need to know that emails are a thing? Why does our service need to know about credits and all of these things? I'm going to argue that these concerns belong elsewhere. So what is the remedy? The remedy is factoring your code properly. And that means we want to separate our logic from our services. And the CQRS module actually does provide quite a nice structure for doing this. And that structure is an event-driven architecture. So we want to separate our implementation from our services. We want to declaratively say in our service layer, this is supposed to happen, and then handle it somewhere else. So if we take a look at how that might look in Nest, here's our checkout method, and it's all better now. We have this command bus, and we're executing a checkout basket command. We're done. This is nice. Thank you. No, commands are one part of the puzzle. What is this command? It's a class. There's a lot of classes. We're going to do a lot of classes if we're writing Nest. Sorry about that, but that is a limitation because of the Reflect Metadata API. I look forward to a future where we can do dependency injection using the type system for functions and interfaces. It's just not where we're at yet. So we'll be seeing a lot of classes. But this is a simple class, nothing too much to complain about. Has a user ID and a basket ID. And now we're done. No. We need to handle this command somehow. And how do you handle commands? Well, you make a command handler. And you can see there's a bit of boilerplate here. We're at the top, we're saying, okay, dear Nest, this command handler here is going to handle the checkout basket command. And it's a class and it implements some interface. Great, let's get rid of the boilerplate. Let's look at our code. Here we have an execute method, and what's happening here is we are getting our basket, we're getting our user, and we're telling the basket to check out with the user, and then we're calling this commit method. And that's very similar to what we were doing before, but notice we're not saving anything to the database. But the reason we need this comment there is because something teeny tiny changed in the implementation of this checkout method when we started using the CQRS module. So let's take a look at the checkout method of basket. And in here, we're modifying our local state. We're saying we're checked out, and we were checked out by this user. And then there's this new concept of an event. And we're saying basket checked out event with all of these properties because events are nice. And please notice that we haven't actually written anything to the database yet. And like commands had command handlers, events have event handlers. So if we take a look at how that might look, an event handler. And this event handler is handling the basket checked out event that we just dispatched from our model. Again, a bit of boilerplate, so let's get rid of that. Let's look at the meat. What's happening here? We're getting some properties from the event, and then we're saving things to the database. Great. That was easy. We're done. Except marketing. Forgot about marketing. Tends to happen. We still have those marketing demands, and where do they fit in this? This is where Sagas come in. And Sagas are a concept that listens to an event and dispatches a command, sort of completing our circle. So an example of that might be something like this. We're listening to events where you will notice probably if you've used RxJS before that under the hood, this is all streams. This is RxJS observables. So when we were using the command bus and the event bus and all of those things, they're really just a facade for an RxJS observable. So here we're able to use RxJS operators to make these sagas. So we're piping all of the events that are flowing through the system. We only care about the basket checked out event, and we're filtering. We're saying if the user's age is over 21, then we're going to map it and send a new send coupon command. So RxJS is doing the heavy lifting, and Nest is doing the heavy lifting. We're just sort of declaratively saying what's going to happen. And the credits, we have this new event in our system, coupon sent event, and filtering by math random. And then we're giving some credits through a command. So to summarize, we have our commands that are executed by our command handlers, which in turn dispatch events, which are handled by event handlers. And then we have these sagas on the side listening to all the events and dispatching commands, or this ASCII diagram here, where we have our command handler, events, event handlers, and then this saga is completing the circle. So just want to show you that this works. So I'm gonna swap over to mirror display. So the AirPlay is mirroring lounge, and I will mirror my built-in Retina display. Here, what's gonna happen? There we go. Okay, cool. So this is actually the thing. Did I? Mm-hmm. Oh, okay. Like so. Is this good? No. Mirror built-in Retina display on the AirPlay lounge. There we go. How's this? Is this better? And then mirror built-in Retina display on the TV too. There we go. Right? What the? No, it's both mirroring lounge. This is very strange. If I try it this way around. There we go. Is it? How's this? No? Okay. We will have to be happy with some of this. This is very complicated, Einar. Okay.
We'll make it better. This is fine.
There we go. Okay. So this is the application we were just talking about. It's factored into commands, events, models, repositories, and Sagas. And in the end, we're bringing it all together in this module that tells Nest what's available for the dependency injection, and Nest takes care of setting it all up for us. Sorry. How is this? Better? Okay. And here we have the Nest factory telling it to create the app module, and we're listening on port 3000. These are the comments we were just looking at. Here's the checkout basket. It's all there. So if I start this up using yarn start dev, and let's clear this. Can everybody see my terminal? How's this? How's this? Okay. So we have our basket service up and ready, and I'm just gonna check out the thing using a GET request because this is for demo purposes. So just piping it through JQ, we can see that we're getting, you know, the basket back. Here's the user that it was checked out by, and we're now at negative 12,000 credits. And if I do this often enough, eventually I will get the 3 million credits into the credits thing. There we go. So it all worked. And if we take a look at our logs, we can see, yeah, we sent an email every time. Here's a alcohol coupon. Your coupon is, you know, some number. And then finally, we gave some credits away.
Where are you storing the state? Where are you storing the state?
Locally in memory, because this is for demo purposes. Yes. We can take a look at that. Here's the user. So yes, now I need to go back to the mirroring, and then I can say thank you, and if you have any questions, feel free to ask.